Hi all, welcome to the video. In the previous few videos around anomaly detection, we studied how we can basically define an anomaly, and then we also looked at typical application and use case where anomaly detection can be applied. Now in this video we'll look at what are the typical anomaly detection models and what are the scenarios or what type of models are typically suited for anomaly detection. Now, if we see in any machine learning model can be of two types. First is an unsupervised and then is a supervised problem. Uh, let's look at applications, or let's look at areas where anomaly detection is not commonly used, or the setup where anomaly detection is not commonly used. These are supervised cases. Uh, Hardly ever you would come across a case where you have labeled instances of anomaly and you have to fit a supervised model. That is hardly a case. And if at all we have a supervised setup, then it becomes very easy to model that situation. You can use any classification model for basically solving that problem. These classification models are like logistic regression, decision trees, random forest, or any forest-based approach. Now, most common scenarios or setups where we have to solve anomaly detection problem is an unsupervised case where we don't have labeled instances of whether a particular record or whether a particular transaction is an anomaly. So in those cases, we basically use two common approaches. One is a frequency based approach and other is tree or a tree or a forest based approach. So first we will look at a frequency based approach. uh, in a frequency based model, what we do, we try to basically divide our data set into intervals, and based on whether a particular observation lies in the interval, it is provided a certain score. So and then based on that score we determine whether it can or it might be an anomaly. So the most common approach for frequency based model is a histogram based outlier scoring, which is also known as HBOS. Uh, Again, as I said, the entire data is divided into interval, and then based on whether an observation lie in the interval or not, it is provided a certain score. And then once we have scored all the observation, we then try to do an exploratory analysis or a post scoring analysis to determine the threshold above which a certain observation may be an outlier or not. Then there are tree based models. The most common tree based model is an isolation forest. Again, here also we don't have a supervised setup, we have an unsupervised setup. So we basically try to first identify features which might impact an observation's probability of being an outlier, and then we basically use an isolation forest. uh, so this was kind of a high level overview of how things are when we are dealing with an anomaly detection problem. For most cases, I think 95% of the cases, the anomaly detection problems are related to unsupervised modeling approaches. And for unsupervised modeling approaches, there are two main models: frequency based and tree based, and these are pretty scalable. I mean, they can be applied to millions of records also, and the turnaround time or throughput time is relatively small. I hope this video was useful to you. If you like the video, do share and subscribe. Thanks a lot.